In this video, we're going to look at an example of finding the differential of a function. So we're given the function w equals xz e to the minus y squared minus z squared, and we're being asked to find the differential. So in order to be able to find the differential, we first need to find all of the first partials. This is a function of three variables, so we need to find three first partials. Notice I just have one function of x here. The rest we can treat as constants. Derivative of x is 1. So the partial with respect to x is just z e to the negative y squared minus z squared. Likewise, we just have one function of y. So when we do the derivative there, derivative of e to a power is just e to that power. Then I differentiate the power with respect to y. So that's where that negative 2y comes from. Derivative of z with respect to y would be 0, so there wouldn't be an extra term here. The x and z are just constants, so that's constant times function. We get constant times derivative. Rearrange some things, and we get the partial with respect to y is negative 2xyz e to the minus y squared minus z squared. For partial with respect to z, we have two functions of z, so we'll need to use a product rule. Derivative of the first will be 1 times the second, so that's where the x e to the minus y squared minus z squared comes from. That x is just a constant, so it just hangs out. Derivative of the second in this case is we need to do e to a power as derivative. Well, that's e to a power times derivative of the power. Notice this parallels what we had for the partial with respect to y. It's just now we're differentiating the z. And like before, our x went along for the ride. We can factor out an x and an e to the negative y squared minus z squared to make things maybe look a little bit prettier. And we're left with a 1 minus 2z squared in that second factor there. I guess technically that's the third factor there. In any event, now we found our first partials. So to write our differential, we write the dw is equal to partial with respect to x times dx, partial with respect to y times dy, partial with respect to z times dz, and add those things together. So we get partial with respect, difference, the dw is z e to the minus y squared minus z squared dx, minus 2xyz e to the minus y squared minus z squared dy, plus x e to the minus y squared minus z squared times the quantity 1 minus 2z squared dz.